let's talk about web apps. So here's the outline of my talk overall. I'm going to talk about the app that I built, the API for that app, and then I'm going to talk about each framework that I chose individually. And then I'm going to give some final impressions of what I learned while I did this whole exercise. So the premise here is that I built the same app in 4 frameworks. That app is a simple to-do list app. You can register a new account and log in. You can see 3 categories of tasks, things you haven't completed yet but are coming up, things that are overdue, and things that have no due date. You can create new tasks. You can edit existing ones, kind of your simple CRUD application. And you can see information about your own profile and stats about tasks you've done, and then you can edit your profile. When I say simple, it's simple. Right? This is very no-frills web application. There's a 3 list of tasks. This is to create a new one. And this is the API. Every framework that I implemented is using these 7 routes. Simple home routes, /accounts to register a new account. You can log in and log out. You can see your own profile. You can get the tasks all at once or by ID. And here are the 4 frameworks that I chose: Flask, Tornado, Pyramid, and Django. I chose Flask and Django because those are the most well-known out of the Python frameworks, well, ecosystem. And then Tornado and Pyramid because not many people know or use them, but they're actually fairly good, and I like them. I learned to like Tornado. I had no idea how to use it when I started doing this. I chose the descriptions that they use to describe themselves, and I'll give my own kind of high-level summary of what I think about them later on. First is Flask. To start up with Flask is just simple pip install Flask, like with most things, unless you're using pipenv, I guess is the default now, right? That's the recommended way of python.org. I don't know. If I use a SQL-based database, so I use Flask SQL Alchemy for my database interaction, and then Flask HTTPL for some authentication. In my environment, I set up 2 environment variables, one for my Flask app and one for my database URL. I use the same sort of thing for every database URL for all of my frameworks, so you'll see that again and again and again. You have to create your working directory. I called mine Flask to-do because it's my Flask-based to-do list. And then create app.py in your working directory. You don't have to call app.py. I called app.py because of my environment variable. I also called it app.py. And then in that file, you say app.config for all your configuration for your Flask instance. This is what it looks like. This is a fully complete Flask application. It just says hello world. You go to that route for wherever you're hosting this, and it says hello world, and you're happy. So you might want to actually have some persistence on the back end, and for that, you need to connect to database. There is no built-in database manager for Flask. You have to roll your own or use something else that somebody else built. I use Flask SQL Alchemy because it was simple, and I knew how to use SQL Alchemy. Uh-oh, no, okay. Is that a wardrobe malfunction? Your database is incorporated through an update to your app.config. So you have this config object. You just say, if I want to use SQL Alchemy with Flask SQL Alchemy, I use SQL Alchemy database URI, point to some URL wherever you get it from, and that's your database. And then you instantiate your database connection with SQL Alchemy, passing it your app. And then you have your database connection. You can use that to define objects in your application. Every object you make will be inheriting from db.model. So I want to make a car object. I say class car, inherit from db.model, and you get all the great things that come with db.model, including a connection to the database with the .query attribute. Every column you want in your database table is going to be a db.column instance. Every data type for that column is going to be passed into db.column, and then you can set up the keywords for, if you want to have a default value for a field, or if something should be nullable in the table, or if a field should be a primary key. And these are 2 objects, the task and the profile object. I don't expect you to read all this because I'm not that mean, but just the general idea here is you make a class, you make some class attributes for your fields in your table, and then you set the data types for whatever you need them to be. Anything you want to have extra, you have to include in a method. For example, in the profile object, I included in the init method the ability to set the time of creation for the profile. I also set a token for logging in, logging out. You'll see this pattern over and over again with any framework that uses SQL Alchemy, so much so that I didn't include it for the rest of the other 2, Flask and Tornado, because it's just seeing the same slide over and over again. There was one instance where I didn't even change the information on the slide. I would just change like Flask to pyramid or to tornado. So it's just like, why am I going to do that to you? If you want to set up a model relationship, for example, you want to have your profile have many tasks, like a many-to-one relationship, you have to set that explicitly on your object. If you're using a SQL Alchemy-based system, you're going to do this sort of thing where you say, okay, on my many tasks, I'm going to set up a pointer to my one, my profile. I'm going to have a pointer to the ID, and then just this relationship field, which is going to point to the profile. My profile object, if I want to have a pointer back to my tasks, I say here, point back to tasks, and then you're good to go. To initialize the database, again, you have to make it yourself. Even using Flask SQL Alchemy, you don't get a database management script along with it. You just get the ability to talk to a database. And so if you want to make tables or drop tables, you have to say that in a script. You can do a lot more if you use something like Alembic. I didn't. I just said very simply, when I'm in development, I can make and destroy. When I'm in production, I just make, and that's all I'm going to do with that. Here's where the meat of a framework comes into play. For any web framework, your only real job is to take in HTTP requests or HTTPS requests and return responses. That's it. You don't have to mess with models or anything else. You don't have to do any complicated analysis. It's just I see requests come in, I do something or nothing, and then I send a response back. And that's all. And so this is where that web framework comes into play. With a web framework, a view is anything that receives a request and gets called, any callable that you run whenever a request is received. A route is the URL that should be accessed in order to run that function or callable of any kind. In Flask, to assign a route to a view, you say app.route, so you decorate that view with this app.route decorator, and provide as an argument to the decorator the route you want to have connected to that view. And then the return value of your function or your callable is going to be in your HTTP response in some way, shape, or form. This is a very simple view in Flask. It's decorated with that.route. This is /API/v1 / this is my home route. And then it just returns all the routes that I have, and that's all. The return value here is returned using JSONify, which takes my output, makes it into a JSON serializable object, basically just a string, and then returns that to Flask to do whatever Flask does so well. When Flask is handling requests, it has this one global request object that's populated on an incoming HTTP request. So every request that comes in, your whole web framework, your whole system sees the same request object in every function, and can be used not just in your one view function, but anywhere, as long as you have access to the request object. The route variables are passed to your view function as parameters. We'll see that in a second. And if you want to do any sort of database interaction, you have to use that DB object and say, okay, db.session.add or delete or .commit. Commit is when you save any changes you make to the database. If you want to just query the database, you have to do so on the objects that you're querying for. So like if I want to get all my tasks, I say tasks.query.all, and I get all my tasks to the list. Any response you want to send back, you have to build deliberately. So if you want to do more than just send back a simple string, you have to make your whole HTML string or use a templating system to produce your response, but you have to do it all deliberately. And any status code you want to send that's more than just 200 OK, you have to set that deliberately as well. Here's a more complex view. You can see I have is there a pointer on this? No? Yay, OK, cool. You can see my username is a variable here, and that goes right here. The request object up here is being used down here. This .form attribute on the request object takes in any data that comes in on the post request and refers to it by key value pairs, by name. And then here I just make a new task, update its creation time, and add it to my database, and then send a response that says, yeah, you did the thing, it's created, good day. And that's it for Flask. Let's talk about Tornado. The startup and configure for Tornado is fairly similar. You pip install Tornado and Tornado SQL Alchemy. It's kind of like Flask SQL Alchemy. It's SQL Alchemy for Tornado. You have to set up a session secret to sign anything like any cookies you want to send back to the front end. You create an app.py file. You define a port you want to listen on for your server. You instantiate your application object with routes and views, and a cookie secret, again, for assigning your cookies. And then if you want to instantiate and run your server, you pass it your port, and you start your I/O loop, and that starts your server, and it runs until you stop it. And this is what that looks like. Again, a very simple setup for Tornado. It's the same sort of hello world thing, except I didn't include the hello world view because it's a little bit more complex than just def hello view and doing some things. But this is a very simple Tornado application, complete with my favorite session secret, which is Beefy. And I set it to listen on port 8888. You don't have to do that, but that's just a simple default. I know it's always open on my computer. If you want to connect the database, you have to use the make session factory function that comes from Tornado SQL Alchemy. It returns to you a session factory, which you attach to your application object. So here's that application object over here. Just like this cookie secret has a value, you can set up this session factory key value pair on that application object, and now you can talk to your database. If you want to define an object in Tornado with Tornado SQL Alchemy, instead of just using that db.model that you saw in Flask, you have to use the base model object from sqlalchemy.ext.declarative.declarative-base. The main thing that you're going to get from this base object is it will keep track of everything that inherits from it, so that when it comes time to create your tables in your database, you just say, hey, look at my base object, and just create everything that inherited from this base object. Otherwise, it looks more or less just like Flask. There's just no DB in front of everything. But again, every column you want in your table is going to be a column, and this is the column object. Every data type is going to be passed into the column object, or your key value pairs are going to be on the column objects, and define how that table will be constructed. Your views and URL, your views will be classes in Tornado. Every view is a class, kind of like with Django's class-based views. Oh, come on now. I feel like I should just yell very loud. Anyway. You will set methods to handle specific types of HTTP requests. So for a GET request, you make a GET method. For a POST request, you make a POST method. Any routes that you want to have, you have to attach to the application configuration object. And you have to say, here's my route name. Here's a view that's going to handle that route. You can set variables in your route, and those variables will come through on your methods in your class-based view. So here's an example with some more routes in that application object. And then here is a simple view. Every view you want to make in Tornado will inherit from this request handler object. I made two classes here. Two classes. One for my base handler, which just inherits from my request handler, which I use for all my views. And then every individual view will inherit from my base handler view. I did that specifically, and you don't have to do this if you use Tornado, but I did it because there were some things that I wanted to have that were accessible to all my views, like setting default headers and parsing some incoming requests that weren't handled well, or I felt weren't handled well by the request handler. So I did it myself, and then it made every view that I created inherit from that one class. In order to send responses with Tornado's class-based views, you have to say self.write, and you set up what's going to be written in the HTTP body of your response. And that, again, must be, if you're using an API like I'm using it, it has to be JSON serializable, and then you can send it to be whatever you want it to be. If you're just setting up a templating system, like with Django's templates, you just, whatever your rendered HTML would be in that self.write position. With Tornado, the request object becomes an attribute of the class instance. So when the request comes in, it gets added to the class as an instance attribute, and you can use it in whatever method you want to. Any route variables you may have will be in the specific view methods you want to use as parameters. So again, if you're looking to handle GET requests in your GET method, you will have your variable in the parameter list. Your database session, or your database interface rather, was included when you added that session factory on your application object, and inside of the class, you can use it with the session mixin object. It adds a make session method for you that you can use to, surprise, surprise, make a session. And then you still construct your responses in the same exact way, and you can set your status codes and headers deliberately in your class. So here's your base handler, here's that session mixin, And I set up some more methods to do things like convert incoming byte strings to Unicode, set some default headers, and set up my response with a specific status code for every class that I want to have use this space handler. And here's the task list view with two methods. I didn't comment it out, but I zipped up the get method just because you've seen the get method already. I want you to see a post method. And this is how you make a session with the make session method. You use this as future thing in Tornado, which says, so this is where the asynchronous part of Tornado comes into play. Whenever you have a process that would take a long time to run, you say to Tornado, take this function, run it as this future thing, kind of like promises in JavaScript. And whenever it's done, take that and do whatever you're going to do afterward. But I'm going to just hand off control back to my main process so I can take in more requests. So I don't have to wait for my database session to finish in order to take in new requests, which is nice whenever you have long-running database tasks or any other tasks that can be run this way. I use this. I set up the send response function on the last page here. Oopsie. Oh God. Okay, cool. I set up the send response method here, which it just ends up calling self.write, but I can set my headers too. And so I say, okay, here's a message that I want to send through, and here's the status that I want to send it with, and then everyone's happy, and we can make our web app go and do what it's supposed to do. Pyramid. I like Pyramid. So I'm a teacher, I teach Pyramid. And when I teach Pyramid, I'm lazy, and I use the cookie cutter SQL Alchemy scaffold to build my project. So I use it here too. There are cookie cutter scaffolds for all of these frameworks, but I really only understood this one, and I had very limited time to work on it, so I use it with Pyramid and nothing else. So you pip install Pyramid, pip install cookie cutter, go through the prompts of cookie cutter, install a template code, and in your application's root, you want to point the SQLAlchemy.url setting to your database URL. Otherwise, it's all more or less the same. When you install Pyramid, it installs for you several command line scripts to serve your application in development, to access the shell, which is aware of your application, and to manage your database. This is the first one where you don't have to roll your own database management script, which is nice. When you use the cookie cutter template, this is all that it gives you. This init.py file is what holds the main part of your application, as well as including your central configuration, which hooks in your routes, your views, and even your models if you have those models. Here, in this one particular place, you want to override your default settings, which would come from one of these INI files, like development or production.ini, to say, hey, SQLAlchemy.url, point to my one database URL in my environment, not some hard-coded thing in my INI file. This is, if you're in the line of doing the 12-factor application, you want to do it this way and not have anything hard-coded because it's just not good. When you're connecting your database, you just, like I said before, point to your database URL and then include any models you want to have wherever they exist in your setup. This is just where I put my models. This is where the template suggests you put your models. You don't have to. You can do whatever you want to, but make sure you know what you're doing when you do that. Pyramid leverages SQLAlchemy directly. There is no Pyramid SQLAlchemy package, and so whatever you see that comes next will be from SQLAlchemy directly. When you want to initialize your database, the script is given for you. It's called, conveniently enough, initialize_db.py, which, as you might imagine, initialize your database. It accesses that same base object that I talked about before in Tornado, which again keeps track of every object that inherits from it. And so you can just say base.metadata.dropAll or createAll to talk to your database and just set up all your tables or drop all your tables or do whatever you want to with that. The template even includes for you a script in your setup.py to make your database management easier. You can just say in your command line initialize DB or initialize app name DB, and then it'll know where to look for this function, run this function, set up your database, and it's more or less clean from there. For views and routes, all your views, well, all the views that I made were function-based views. And whenever you want to connect a route to that view, you have to say it explicitly on the view as a decorator with a view config decorator. You have to declare your route separately, where you give it a name and then the actual pattern for your route. I used F strings. just for this pattern. I didn't want to write it like 10 times, so I just did it once and copied it 3 times. this is an example of that same info view that just lists out my routes. Here I say, I can do this over here. This is weird. Okay. View config decorator. Here's my route name that I want you to attach to. Here's how you're going to be rendered. If you don't want to render it as JSON, you can render it as something else like a string, or if you're using Jinja 2 to render templates, you can put that there as well. And the method you're going to be handling is only get methods. And you just send back all the routes that I have in this app. The request object gets passed by default to the view function on receipt. So you have to have that first argument in there. You have to say, here's my view, parameter list. The first argument must be the request object. You can call whatever other parameter you want to request, but the first thing is always going to be the request object. Any URL variables will populate a dictionary on the request object called a match dict, and you can pull data out of the match dict from there. The database session is also attached to the request object. And so if you want to do anything with your database, including query, you have to say request.dbsession dot whatever you want to do. Any responses you want to send back are the return values, like this one here. You must make them a serializable dictionary, even if you are using a templating system. And then if you want to set status codes and headers, you have to do that specifically on the response object. And so here's a more complicated pyramid view, where we make that same task object. We set its date of creation. We talk to the database here. We say, I'm going to add the new tasks that I made. I'm going to set up the header on my response to be an application JSON. I'm going to set the status code to be 201. And my message is going back to the front end is going to be posted this new thing. Anytime you send a post request and you want to receive that with pyramid, you have to access the post dictionary, kind of like that form dictionary in Flask. It's all the same stuff. And your data will just be there as key value pairs. Django, the big daddy. Pip install Django and DJ database URL, which is awesome. I love that so much. And Django REST framework if you want to use an API like I used here. Django gives to you the Django admin, which is the thing that lets you manage all your Django stuff, like starting a new Django project, like Django to do. In your environment, you can set up a database URI. You can set debug to be true. These are settings that are going to be in the settings file, which I abstract out to the environment, and some secret key that, whatever you want it to be. Your URLs will all be in one file called urls.py in your application root. You can put other URL files wherever you want to, but if your URLs are not in that file, they are not seen when Django is run. Same thing with your setup. If you want any settings, they must be in settings.py. If they're anywhere else, you have to point them explicitly, or they do not exist to Django. This is a very, very, very compact settings.py file for Django. It does not include many of the many things that are in the file, only the things that I modified and that are important for this talk. You set up the secret key and your debug, which comes from your environment now. Your allowed hosts in production will be populated with your actual allowed hosts that you can host this site on. Any app that you make with Django will be in your list of installed apps, and your database will point to some database. You can set up in any way you want to. I use DJ database URL because it's great. I just give it a URL, it parses it apart, and it knows what it wants to do with that URL. When I originally wrote this talk, that was 3 slides instead of 1 because it's such a damn big file. As you saw before, any database you want to include is included via the database's setting in settings.py. Django comes prepackaged with its own object relational mapper, which is what SQL Alchemy is. So it doesn't need to use SQL Alchemy. It uses its own. It does assume, though, that you want to use a SQL-based database. And so if you want to use anything else like Mongo, well, good luck with that. Any models you want to create will live in their own smaller apps. And if you want Django to see your model, it must be included in your installed apps list, or else it doesn't exist. If you want to define an object, you have to inherit from the model object that Django gives you. And so you have to import django.b.db and get models.model, and every class you make is going to be a models.model instance. Every field, instead of being a column instance, will be a field instance, but it's all the same stuff underneath. Any field-specific values like default values or nullable fields or primary keys must be set explicitly on the field objects. We'll see that in a second. And I didn't have to make a profile object because the user object already comes with Django. I guess they assume that you're going to make a web app, you're probably going to need a user, so here's a user, go have fun. And so I just made a task object, which is nice for me. As I said before, instead of making column instances, you just make field instances, but again, it's all the same stuff underneath. The one big change is that with Django, especially with datetime fields, you can have this auto now add thing which says, when you make a new version of me, keep track of that date time and don't ever update it ever again. Otherwise, it's all the same stuff. The other major difference is that you don't have to explicitly set the ID field. It automatically populates when you make a new instance of that object. Model relationships are simpler. If you want to do a many to one or one to many, you just set a foreign key field on the many, point to the one, and then you're good to go. When you want to initialize your database, you have to use the manage.py file that Django gives you when you make your Django project. Any app that you want to have recognized by Django must be in your installed apps list, and you have to say make migrations to take a snapshot of all your database setup, and then migrate to actually copy your migrations to your database. I'm running out of time. Here's a list of Django URLs, patterns, blah, blah, blah. You've seen routes before. You're intelligent people. Here's a class-based view with Django REST framework. Same stuff as before, JSON response. Setting up, handling requests, saving and deleting models. Every model has its own connection to the database, and I have to stop right here because I'm being called on time. There's my kid. He's adorable.